Hello friends, welcome to Teach Me. In this video, I am going to explain you the key concepts behind recursion. Before going into recursion, let us first understand why do we write a simple function. Okay, in your program, you can sometimes there might be cases that the same code will be repeated somewhere else in your program or many times in your program. So instead of writing the same lines of codes again and again, what we do is that we put the same lines of code inside a function and we can call the same function without writing the same lines of code. We can just call the function to execute the same tasks in your program. This is the main reason we write a function. By writing a function, you can reuse the code again and again by not writing the same lines of code, but instead by calling the simple function. So functions are very useful and efficient ways of problem solving in programming. So what do you mean by a recursive function? Okay, if you just see this part which I am marking, now here it is also a function, but you can see something strange happening in this function. What can you notice is that we have written a function called additional. So if you see here, within the function itself, we are calling the same function that we have written. That means we are calling additional again here itself. So what does this mean? This is the key example of a recursive function. So the definition goes by this. If you call a function within the same function, then it is called as a recursive function. Okay, now I am going to explain you this concept with a simple example. Okay, so what does this additional function do? So it's very simple. It gets an input parameter called a. So if a is less than or equal to 1, it just returns 1. If it is not, what it does is that it returns the input value a plus it calls the same function additional with a parameter of a minus 2. Input parameter of a minus 2. Okay, so this is a simple function that does some mathematical logic. So now let us assume that we are calling the first statement. So what happens is that we are calling additional of 5. So what does it how does the computer understand? First it will go to additional of 5, right? So instead of additional, I am putting it as capital A. So now the computer needs to find additional of 5. Okay, so what it goes inside the function, it sees that if a is less than or equal to 1, which is obviously not, so it will not return 1. So what it will return? It will return, what is a? 5 plus what does it have? Additional of, what does it have? 5 minus 2 is 3. So it will look for a of 3. Okay, so now this a of 3 is again called, right? So what is a of 3? So what is a of 3? What is a of 3? So again it will pass the input parameter 3. So what will happen? It is not less than or equal to 1. So what will happen? It will come as 3 plus, what is a of 3 minus 2? It is called a of 1. So now the computer needs to find a of 1. So it also does not know the value of a of 1. So what it will do, it will again call the additional function with the input parameter of 1. So now int a is 1. So if a is less than or equal to 1, yes. So what it will do, it will return 1. Okay, so after return statement the function is closed. So it will not go for return a plus additional a minus 2. So we can get the output. So what we got is a of 1 is as, we got the answer for a of 1 as 1. Right? Okay, so now the computer will calculate 1 plus 3. So what is 1 plus 3? 4. So what is 4? 4 is nothing but a of 3. So instead of a of 3, we can replace it as 4. So what is 4 plus 5? 4 plus 5 is 9. So what is 9? 9 is none other than a of 5. So now we can easily understand that what we call is that a of additional of 5. So what is additional of 5? 5 plus 4 is 9. That is why we get the result additional of 9. So can you understand the key concept of recursion? It's actually very simple. Even though recursion appears to be hard at first, if you go at simple steps and understand the key concepts, recursion is a very easy and efficient way to solve complex problems in programming. Another classic example of recursion is factorial problem. So what we'll do is 5 factorial. What is 5 factorial? 5 into 4 into 3 into 2 into 1. Okay. So for example, so factorial is a classic example of a simple recursion problem. So I will write it. What is 5 factorial? If you see here, 5 factorial means 5 into 4 into 3 into 2 into 1. So can you see a relation between the input? So 5 is nothing but A. What is 4? A minus 1. A is nothing but A minus 1. What is 3? A minus 2. So by right, only the input changes, but the programming logic does not change, right? It is going to call the factorial method only. What is 4 factorial? 4 into 3 into 2 into 1. What is 3 factorial? 3 into 2 into 1. So the logic is same, just the input changes. These are the classic examples of a recursive function. So I hope this would have opened a key concept in programming called recursion to you. I hope you just not rely on this particular example alone. Try a lot of examples on your own, understand it more, and do it practically so that you can understand much more about programming and recursion. Thank you. If you find this video useful, kindly share it with your friends and help us the channel by spreading the word. Thank you. Thanks a lot for your time. See you in my next video.